Alright guys, so now we are going to talk about the lecture 6.1, inverse circular function. So what's the main idea? An inverse function computes the input required for a function to give a desired answer. The trigonometric functions have inverses, but only for a restricted interval of their domain. So what you should be able to do is to state the output of the inverse trigonometric function for key values and use calculator to compute the output of inverse trigonometric function for other values. So I will let you read this vertical line test, horizontal line test, inverse function. These are very important because it's derived from the algebra. So please take a look at it. Then let's try to practice a little bit, and let's try to look over the problem number 1, so that the inverse of f of x equal x cubed minus 1, it's the cubic root of x plus 1. So I tried on the side right here to do the problem for you. So first of all, I express y, I substitute the x by y and the y by x by y and the x by y by x and x by y, and then I express y by himself. If I want to make sure that the function f of x that I have right here and the inverse function that I calculated is correct, I just need to do the composition of the two functions, f minus 1, the function that I call g of x, which is the inverse that I calculated. And if I found that the composition of the function and the inverse I have calculated is equal to x, that means I didn't make any mistake in the calculation of my inverse function. You will also notice that the function and the inverse function are symmetric through the line y equal x. So, number 2, state one way you could restrict the domain of f of x equal x squared to make it one-to-one function. Based on the vertical line test, it has to have only one point of intersection, and so therefore it defined a domain between minus infinity and plus infinity right here, or it defined a 0 plus infinity right here. So minus infinity to 0 or 0 plus infinity. Now let's try to work on the inverse sine function. So y equals sine to the minus 1x, which is also written as y equal arc sine of x. And that means only that x equals sinus of y. So first of all, you will note the domain of the sine function has to be restricted to make it one-to-one function. Remember, we have to always be in one-to-one function in order to define an inverse. So first of all, if I have y equals sinus 1 minus 1 of x, to define that x equals sinus y, I take the sinus of y, I take the sinus of sinus minus 1 of x, and at the end of the day, I end up to have sinus y equal x. Sinus x is not a one-to-one function. It must be restricted. We must restrict the domain to find the inverse, okay? And the restriction has to be between minus infinity, minus pi over 2 and pi over 2, okay? So this is the restriction right here. All right? Okay, so let's try to practice and work on the practice number 3. Find y in each equation. Well, you have y equal arc sinus square root of 3 divided by 2. You are going to take the sinus of y and the sinus of arc sinus square root of 3 divided by 2. Well, the sinus y will be sinus y, and the sinus of arc sinus square root of 3 divided by 2 will be square root of 3 divided by 2. All right? And what is the value of the angle that gives you the sinus equal square root of 3 divided by 2? The angle y equal pi over 3. Y is an angle. I could do exactly the same thing for y equals sinus 1. Sinus minus 1 of negative 1 over 2. I take the sinus both sides. I end up to have sinus y equal negative 1 over 2. And the value and the only angle will give you the sinus of this angle equal negative 1 over 2 will be negative pi over 6. If I do the same for the other one, I end up to have sinus y equal sinus of sinus minus 1 of square root of 2 divided by 2. Therefore, sinus y equal square root of 2 divided by 2. And so y equal pi over 4. Okay? Now, I can go back and say, for the last one, sinus y equal the sinus of sinus minus 1 square root of 2. That implies sinus y equal square root of 2. So therefore, y equal, and I let you do that, and I let you find this one, okay? And I will ask you a question on that puzzle on this one. All right, so let's try to move on to the graph of sinus minus 1 of x, which is the graph of y equal arc sinus of x. So, if you are looking at what basically you are going to have on the y-axis, on the vertical axis, sorry, sinus y, and on the horizontal axis, x, okay? So right here, you have sinus, actually you have y, sorry, right here, you are going to have y, and right here, we are going to have x. And what we are looking for is graphing y equal sinus minus 1 of x. So we're trying to graph the inverse of sine function. So sinus y equals 0 when y equals 0, or when y equal pi, or when y equal 2 pi. Okay? Sinus y equal 1 when y equal pi over 2. Sinus y equal negative 1 when y equal negative pi over 2 or 3 pi over 2. When you look at your trigonometric circle, that's pretty easy to realize, to find this value. Therefore, when I want to graph y, function of x, which is basically graphing the inverse of a sine function, I will just have to plot for each value of y, okay, for each value of y, the value of sinus y. All right? All right? We good? For each value of y, the value of sinus y, which is the value of x. All right? So what I'm going to do is I'm going to do this right here. And this will be the value of x. Okay? And you have all the correspondent value of y right here. So the inverse sine function is increasing and continuous on its domain. X and y intersect are 0, and the inverse sine function is an odd function. So on the inverse cosine function, it's the same idea. The domain of cosine function has to be restricted to make it one-to-one function in order to define an inverse function. Okay, so let's jump to the practice, and we have y equal arc cosinus of square root of 3 divided by 2. So if I do the same, if I apply the same idea, cosinus y equal cosinus of arc cosinus square root of 3 divided by 2, which is giving me cosinus y equals square root of 3 divided by 2. And what is the value of the angle that give me the cosinus of that angle equals square root of 3 divided by 2? The trigonometric function values are giving me y equal pi over 6. Same idea for the number, if I call that the problem number 1, that could be problem number 2, 3, and 4. I did for you the problem number 4. I will let you do the problem number 2 and 3. You will realize in this problem number 4 that you cannot have an angle that gives you a cosinus equal number 2 because you know that the cosinus of an angle is in between -1 and 1. All right, so let's move on to graphing this function. I let you do it. You have everything you need. It's the same idea that graphing is the inverse of sine. So I let you work that on your own. I let you also remember that the inverse cosine function is decreasing and continuous on its domain, and the inverse is neither odd nor even. Domain -1, 1, and range 0 pi. Let's focus now on the tangent. So on the tangent, what do we have? First of all, we have vertical asymptote. We have vertical asymptote, and let me do that, and I'm not going to, I don't have a lot of time. So we have a vertical asymptote right here. And this vertical asymptote for tangent function are going to be transformed. So these are vertical asymptote green. There we go. Vertical asymptote for tangent function. And this vertical asymptote for tangent function are going to be transformed into horizontal asymptote. Horizontal asymptote for the arc tangent. For arc tangent. All right, so now let's focus on the practice number 5. Same idea. What I want to do is I'm going to have tangent y equal square root of 3. And by the way, of course, right here, it's a tangent. Right there, I'm going to have tangent y equal 1, tangent y equal -1, or tangent of y equal square root of 2. That will be for an angle y equal pi over 3. I will let you look at the trigonometric circle function value. Y equal pi over 4. This one will be for y equal -pi over 4. Please look at the trigonometric circle function because you will have to do that on the exam. And the last one is allowed because that will give you a value of y around 59 or 54.736 degree, okay, which is about 0.9553. All right. Now let's move on to the next part, which is graphing the y and the inverse of your tangent. I'll let you do that. You have everything you need, all the value of x and y to graph the inverse. Same idea. If you have any question, please ask me during the class, when you will be in class. The inverse of the function is increasing and continuous on its inverse, on its domain. The inverse of a tangent function is odd, and you have the domain and the range. All right, so now let's work a little bit of different things. First of all, if you have y equal cotangent, the inverse cotangent of x, well, that means that cotangent of y equals square root of 3. You know, you are taking the cotangent of y equal the cotangent of cotangent minus 1 of x, and that gives you cotangent of y equal square root of 3. And actually, this is where we don't have x right here. We have square root of 3. We have right here square root of 3. And that implies y equal pi over 6. Pi over 6. Okay? Because it's corresponding to cosinus pi over 6 divided by sinus pi over 6. And when you do that, you find square root of 3. All right, guys, so I don't have a lot of time to finish that. So you will have a second part where you will have a little bit more information to end for this section 6.1. Thank you very much.